Hi everybody, this is JJ here at Newegg Studios, and I'm here along with my cohort from AMD, Don, and we're going to be talking to you guys about, I think, something that's pretty awesome. It's the introduction of a brand new processor, specifically AMD's brand new second generation Ryzen series chip. And in fact, there's actually going to be 4 of them. We're going to be going into a lot of details about them, as well as on ASUS's side of the fence. Of course, there's a lot of motherboard action for the brand new X470 chipset. So I think we've got a lot packed in here. We're going to be talking about architecture. We're going to be talking about improvements to the chip design, of course, overclocking, motherboards, features, and functions. We've got some demo stuff baked in, a little bit, I think, of everything. So if you guys are interested in building the latest and greatest when it comes to AMD's Ryzen-based platform, this is going to be a live stream for you guys. So, Don, why don't you go ahead and introduce everybody out there on the stream?
Hey, everybody. JJ, please call me Donny.
Donny, got it.
Donny Woligroski here. I'm technical marketing with AMD. I do some business development, and I'm very close to the Ryzen line, very dear to my heart. Really excited to be launching it today, along with ASUS and the X470 boards.
So I think first and foremost, let's go ahead and kind of get right into it. To give people, I think, a little bit of a recap of where we are. Right, this is of course now an update to the previous generation, first gen Ryzen part, which is a long digestion in terms of the work and development to be able to release that part, and then of course X470 is a follow-up to X370. So why don't you go ahead and just give us some insight in terms of where we're at specifically with what's new. What do we have in terms of the processors, positioning, kind of performance expectations, kind of. Give us what Ryzen 2 is all about, Ryzen second generation is all about.
Absolutely. And maybe it helps to give some context to where we came from. So we launched the original Ryzen about a year ago, almost exactly, in March 2017. To great fanfare, we have a really high performance part with really great IPC, and at the same time we offer a ton of cores and threads and processing threads. So we really changed the game for content creators, enthusiasts, people who really appreciate multi-threaded software, and just tried to really move the needle for what people can get out of their PCs. And we really succeeded, I think. Had a great year. First gen Ryzen parts, it really did change the landscape. Having said that, there's always room to improve. And so we've come out with the second gen Ryzen today. And if you guys can scoot on my screen there, I'll show you the new models. Well, that looks a little skewed. Is that good? While they're looking at that, I'll talk to the new model. So the first gen Ryzen, Ryzen 7 processors have always been 8 cores and 16 threads with AMD's SMT technology. So we essentially virtualize 2 threads, processing threads from each core. And so we have the new Ryzen 7 2700X. That's taking the place of both the 1800X that was at the top of the stack and the 1700X. So kind of consolidating that. And at the same time, we're bringing it at a lower price than the original 1800X was. We started at $499. The Ryzen 7 2700X, keeping the competition good, is an SEP of $329 US. This new part has a maximum boost clock of 4.3 gigahertz, so that's a little bit more than the original Ryzen 1800X is, which was 4.0. But at the same time, we have some technology that really makes a lot more usable clock speed increases, and we'll talk about that in a little bit. What we've also done is every second gen Ryzen processor now comes with an AMD Wraith cooler. So AMD changed the game.
This is huge.
Yeah, it was really cool. We introduced the Wraith coolers last year. Everybody loves them. It's nice to have a cooler out of the box that's worthy of actually using instead of throwing away and buying an aftermarket one. But we did have a couple models that didn't come with a Wraith cooler.
Yeah.
So now we've heard the feedback. Yes, it was loud and clear. Everybody wants a Wraith cooler. So every second gen Ryzen processor will come with a Wraith cooler in the box.
So I think before we kind of keep moving on in terms of your detail, I think it's important to really not undercut that, right? Because if you talk about from a complete total value proposition, when anybody goes about defining their system build, you have to include the cooler, right? It's part of that. And I think when you're talking about an enthusiast-oriented CPU like what we've got here with every one of these CPUs capable of overclocking, as well as they also have dynamic, essentially performance based on the cooling solution, you guys are essentially kind of ensuring a higher level of peak performance for this part right out of the box because they're giving a much better quality cooler that not only allows for better, let's say, stock performance, right, but also will allow even for some moderate good quality overclocking experience.
Yeah, exactly.
And you don't have to pay anything more. It's right there inside the box.
Whereas with the competitor, if you buy the same class of CPU, you're going to have to buy a cooler. You're going to have to spend at least $40, probably more to get something comparable. And there's so many. I mean, and it's a really good cooler.
Yeah.
We still have XFR, which is extended frequency range technology. So Ryzen processors are really smart. They have a ton of sensors. They pull them every millisecond. And what it does is it checks how much headroom it has every millisecond. Says, can I boost higher? If your temperatures are lower, it takes that into account. It says, yeah, I can kick it up a notch. With the Wraith Prism versus our standard 95 watt cooler, you actually see a performance boost. I think it's about 4%. If you stick on water cooling, you might go as high as 7-8% of a performance increase. That's without overclocking. That's just the CPU being intelligent enough to notice what's going on around it and take advantage of it.
Yeah, very cool. So go ahead and let's finish expanding here on the total 4 models, right?
Okay, absolutely, yeah. So we've got, there's so much information, so let's get started. Our first gen Ryzens were 95 watt X processors. X always means the fastest. Think of it as our version of the ROG line, the fastest, highest performance processors. Those were 95 watts in first gen. And then we had efficient processors. If you've got smaller form factors, you don't want to lose, I should say you don't want to create a lot of heat. And we have 65 watt models. What we did is, because we've improved our architecture and are using the new 12 nano process, and I'll get into that later, but essentially we're more efficient. We're using less power for every clock frequency. Now at the same time, we want to push farther, right? We've got competition. We want to bring it all to the game. So we did increase the TDP of the 2700X 10 watts to 105 watts. So the 2700X is a 105 watt part. It's our fastest part. And it's the one that comes with the brand new Wraith Prism that we were talking about. That's a brand new cooler.
You can actually see right here. We do have it actually set up here on our X470 Tough Gaming board.
Yep, can have a look. And we'll talk more about that later. There's a lot of really cool Wraith Prism features. But I'll just let you look at the delicious moving RGB circle right now. So we've got that 105 watt Ryzen 7 2700X. Then below it, we have the Ryzen 7 2700. So the same 65 watt TDP as the last gen 1700, but much higher clock rates. So now we've got a 4.1 gigahertz max boost clock. Still got that 20 megs of cache, and it comes with the Wraith Spire cooler. Every Ryzen 7 that comes with a cooler comes with an RGB controlled LED cooler. So the Ryzen 7 2700, just like the Ryzen 7 1700, comes with the Wraith Spire with color control RGB on the ring. Plugs into great ASUS boards and our partner boards to allow you to control that color, because everybody likes their computers to look kind of cool. And then moving off to the Ryzen 5. So in the Ryzen 5 segment, our top is the 2600X. That's the new processor. It's a 6-core, 12 processing threads with SMT. It's 19 megs of cache, and it's a 4.2 gigahertz clock rate. Now this is a really sweet spot for gamers. This is a $229 suggested price, and this is a really powerful processor. Now, a year ago, if you wanted something with 12 threads, you were going to be looking at something many hundreds of dollars to get into that. It was just for content creators. People are really serious. Now, it's really a viable gaming chip. It's great for gaming and streaming. You can get into this really sweet spot. People really loved our original Ryzen 5s because of that, because they have a lot of cores and threads, and we're really continuing that now with performance increases, higher clocks, and some architecture increases as well. And then, of course, we've got that Ryzen 5 2600. That's the entry-level second-gen Ryzen for now. It's also 6 cores, 12 threads. It's a $199 suggested price. And the great thing about Ryzen is they're all still unlocked. So you don't have to buy the X model to get an unlocked processor. You can buy the Ryzen 5 2600. It's unlocked. You can play with your voltages and your clock rates and your memory overclocking. We don't hold any of that stuff back. So that's the line.
To recap here, essentially we've got 4 processors. We've got the 2700X, 2600X. The X is essentially a definer to let us know that essentially that's going to allow for the highest level of performance, supports that peak of XFR, and then we've got, of course, the non-X versions, right? 2700 and then the 2600. All of them, like you said, all support overclocking, and of course, when we tie that into, let's say, X470, because there's generally a kind of tie-in when you talk about a chipset to a CPU alignment. Can you give a little bit of context in terms of specifically what is the key benefit of pairing these latest generation second-gen Ryzen 2 chips with X470? Is there a requirement? Because one of the great things is, of course, for us, we have already retroactively released UEFI updates for all X370 base boards, right?
Right.
So that you can go ahead and support these processors. But is there a specific benefit on the CPU side with matching this with a current-gen chipset?
Something we've gone really out of our way, and it's a hard thing to do from an engineering standpoint, is to make sure that your infrastructure doesn't break every generation. And I'm sure we make it harder on you guys too, because you've got to make sure the last gen boards have to work with the newest chips and vice versa. If you have a first gen Ryzen, you want to buy an X470 board, and we'll talk more about the platforms later, but you can take that first gen chip, put it in an X470 board, off you go. You can take a second gen Ryzen chip, put it in your first gen Ryzen board, and off you go with the BIOS update. So the first thing I want to stress is that compatibility is really something we focus on. It's a really top priority for us. We try to make a really smooth experience for our users. Having said that, there's always room to improve, right? So we learned a lot of lessons over the first year with the 300 series chipset, the Ryzen, the A320, B350, and X370, and we took a lot of those lessons, moved it into the X470. X470 is a more efficient chipset. It uses a little less power. It is really optimized. Really think of it as a really highly optimized X370 in a lot of ways. And ASUS has added some special sauce in their boards to differentiate. Another major differentiator is AMD StoreMI technology. I'm going to talk about that. I want to make it really clear that a lot of people might think of software from a vendor like us as maybe not something that they would associate with us, but this is a fantastic storage solution. I've been using it myself since we released it, and I can't talk how great it is. It's fantastic, and I'll explain why in a bit. But really, the main difference between the X470 and the X370 is the inclusion of that AMD StoreMI technology, which we'll talk about in a bit. Yeah.
Okay. So I think beyond that, there's also, of course, some differences in terms, I think, of key memory controller optimizations, right, that have been completed. So for AMD, when you transitioned over, of course, into Ryzen, that was enabling support for DDR4, which was fantastic. We're talking about higher frequencies, bigger densities, better efficiency, all the way around. It's awesome to be able to finally have DDR4 on an AMD platform. But we did see some bump ups. So as there are differences in terms of the actual memory frequencies that are supported officially under, let's say, Ryzen 2 second gen with X470 as compared to the last generation?
Yeah, and that's really more tied to the chips themselves. So first gen Ryzen, the official peak spec was 2667 megahertz DDR4. That doesn't mean you can't overclock it. That just means that that's the official spec. This year, starting with Ryzen with Radeon Vega graphics and with second gen Ryzen, that official spec has moved up to 2933. So we do have more headroom. In the kits that we sent out, we actually sent out DDR4 3400 memory that worked great with our launch kits. All the different boards that we launched with had that support. So that's a big difference too, because Ryzen really does perform better the more memory bandwidth you feed it. Because of the way the architecture is, we attach they're called core complexes in this thing we call the infinity fabric that ties it all together. And the memory frequency is tied to that infinity fabric. So the faster you run your memory, the faster the inside of the chip talks to each other, and you tend to
overall
get more
yielding better efficiency and better performance.
Exactly.
Yeah, so all the way around. So the big benefit that you have is essentially here is that you're just able to go ahead and leverage those higher frequency kits that are now available. We're finally hopefully seeing a little bit of that pricing coming back down on the DDR4 memory side, but it's awesome to be able to see those improvements. So recapping there, got 4 awesome parts. We've got the improvements in terms of architecture. There's been improvements in general IPC performance. We got the StoreMI technology, DDR4 enhancements, but I think specifically, when we talk about this being an enthusiast-based chipset, enthusiast-based CPU, right? I think 2 of the really coolest things, you've touched on them a little bit, have been XFR and precision boost, right? So can you give a little bit of context in terms of specifically what improvements have been made for this generation compared to the last generation? Because initially on value, it might seem just kind of like version 1 to version 2. It might not really seem like there's that much of a difference, but it's actually pretty substantial in terms of how you guys went back to revisit how you're able to go ahead and dynamically approach essentially clock ramping under different types of scenarios while leveraging those integrated sensors within the CPU.
Yeah, okay. Absolutely. Can you guys show my laptop screen here for a minute? And I'll talk to you specifically the improvements we made that really squeeze more performance out of the Ryzen chips. There's really 2 big advancements that we've made. Precision Boost was launched with our original Ryzen chips, and XFR was launched with our original Ryzen chips. Precision Boost was the chip's ability to intelligently look at itself and say, can I boost more? You know, how high can I go? If I have enough thermal headroom, if I have enough performance headroom, can I go even past my maximum boost clock that we've spec'd out in the chip? And so that was the first gen. Precision Boost 2, we've done something quite a bit different with it. So as you guys can see on the slide, our first gen Ryzen would only max boost with the first 2 threads that it was being used. Because generally when we were speccing out the chip, our engineers felt that if you were using more than that, we should bring the clocks down. It was kind of an arbitrary clock limit to about 3.7 gigahertz, I think, on the 1800X. So basically, if you were using more than 2 threads, your max boost clock would automatically drop. What we did starting with Ryzen with Radeon Vega graphics actually, and now with second gen Ryzen, and it makes a lot more difference on second gen Ryzen because we have so many more cores and threads. What we've done is we had an algorithm now that, because there's some games that'll spawn, like Dota 2 will spawn a ton of threads and use them all at 2 to 4%.
Right.
It's not pushing a lot of thermal problems at us. So the chip's smart enough to say now, okay, I can boost a bunch of cores now instead of just, I don't have to arbitrarily drop after that 2-thread limit. Because
there's no heavy load that's essentially that's limiting you, right, from that thermal and that power perspective.
And even if there is a heavier load, it's just not an arbitrary limit. It's smart enough to look at its environment and say, okay, I can still go a little higher. So really a lot of the multi-threaded performance gains, if you look at the raw clock rates, the difference between Ryzen and Ryzen second gen might not be as astronomical as you think, but when you look at a lot of the multi-thread performance, it's like, wow, sometimes, you see this crazy, 20-point increase over the first gen, and that's a lot of the reason that Precision Boost technology update that we did. And of course that really ties into XFR. Now we've called it XFR2 with second gen Ryzen, mostly because it doesn't have that arbitrary limit, so it can get into those XFR boost states if you have a better cooler with more cores being stressed. So you're going to see higher clock rates across the spectrum when you've got multi-threaded software running. So really important basic increases in how the chip runs and how it performs in certain scenarios, and we're really seeing that. If you guys have checked out any of the launch coverage we had, really positive coverage today. It's really a great day for us. I'm quite happy because it's very gratifying to see the product that you've worked on for a while as an enthusiast, right? And somebody who is lucky enough to be in some of the board meetings where we're trying to decide how to make things better and hear really smart engineers talk about some ideas. It's really cool to be able to offer people a meaningful increase in performance again after only 1 year.
Yeah. And I think tying some of those things back into maybe kind of some real world perspective, as well as some things that I think that enthusiasts might be interested in seeing, is that for the performance that you're overall offering, it's overall better efficiency. So at least what we're seeing is that the overall power, right, you're essentially getting more performance at roughly about the same essentially power envelope, if not even a little bit less, while also even getting higher frequencies. So all the way around, you guys really just took what was already a great performing part and really kind of just pumped it up a bit more to be able to offer, I think, across whatever the usage model is going to be, better performance, whether you're talking about a little bit more lightly threaded workloads, or of course, definitely as you step into those more multi-threaded workloads, you're definitely going to get really nice performance uplifts.
Yeah, exactly. And a lot of that ties into, so Ryzen, second gen Ryzen is the first chip to ever be built on the new 12 nanometer process. And that gives us...
So for those of you guys not in the know, you're probably aware, that's your lithography, essentially. It's just how your chip is ultimately designed, what it's fabricated on, and as we can kind of shrink those things down, generally you're able to, hopefully under different kinds of scenarios, maximize performance in different types of ways. Performance can be a lot of things. It could be, voltage efficiency. It could be CPU frequency scaling. It could be a number of different factors. But you guys were able to do, I think, a little bit of everything in this regard.
Yeah, a little bit of everything. Now, this isn't a major update, but it's significant enough that it really helps the chip perform better. So basically, like you're saying, when you shrink the die, I mean, think of it like the smaller the die you have, the smaller the traces are in the processor, the faster it works. Generally more efficient. So we're using less power. If you look at the Ryzen 1600 versus the 2600, both 65-watt chips, at the same power envelope, if you put them both at the same clock speed, we tend to use, at the same fixed clock, significantly less power, right? But in the same power envelope, we'll get more performance. And then on top of that, like I'd mentioned before, then we gave the 2700X even a bigger power envelope. So just trying to squeeze the most performance out of the top end part, still give you those efficiency benefits in the in the 65 watt part. So a really nice spectrum for folks.
Now, we're going to get a little bit later, of course, into definitely talking about overclocking and some improvements, but I think also important to kind of just touch right here from the very beginning is that there's definite improvements in terms of the overclocking margin. I think in the previous generation, you were seeing ceilings usually in around that, let's say 3.9 to maybe 4.1 gigahertz. I think this generation, you guys feel much more confident seeing that a vast majority of CPUs, for one, are going to be able to comfortably hit 4 gigahertz, no problems, and definitely are going to be seeing 4.1, 4.2 plus frequencies, which when you consider the amount of threads that you're running at the price points that you're having, with the cooler being able to provide even that level of performance is pretty impressive.
Yeah, it's I mean, getting higher clock speeds is always a juggling act, and it's certainly not one of the easier parts of it. But we're making really good progress. And remember, this is not an all new architecture. This is a tweaked architecture on a tweaked 12 nanometer process. Even though those are fairly significant limitations. First gen Ryzen, you could expect 3.9 gigahertz all cores. Mm-hmm. If you were lucky, you might get 4.0, 4.1. Second gen Ryzen, I haven't seen a chip yet that really wasn't able to hit 4.2. That's not saying they're not out there. I'm just saying I haven't seen one yet. Generally, that seems to be a pretty safe range for the 2700X, and further as possible. So we're moving forward. We're taking steps, and that's just with a small architecture tweak. And then, of course, we've got more good things to come in the future. But meaningful increases for people. Certainly more room to flex if you're an overclocking geek.
Very cool. Very cool stuff.
Yeah. And then, of course, some people were worried because when we released our Ryzen with Radeon Vega graphics earlier this year, mm-hmm. We did not use a soldered thermal interface on the heat spreader. And people were really concerned about that. That's not what we're doing with our high-end parts. Second gen Ryzen still uses that soldered heatsink IHS. So still have that. You don't have to go and pay a guy $300 to go delit it and put soldered spreader on it. You're good.
And I guess speaking to that point, how are you guys handling temperature monitoring? Do you guys have offsets for this generation again that some of these people might need to be aware of, or how's that being managed this time around? I think there was a little bit of revisions here again for this CPU refresh compared to the first generation.
I think this was more of a matter of with the first gen, really those temperature offsets were never meant to be seen by users, and we just weren't, I think, prepared for it at the time. We've certainly learned our lesson. So now your motherboards and your
everything's baked in.
Utilities are baked in. You'll see the right temperature. You won't be assuming it's running too hot when it's actually running really cool.
Yeah, and I will say that again, batting to the kind of the whole thing that we've been talking about here with improvements in efficiency, voltage, that the actual the temperature performance is actually, I think, pretty good for the frequencies that you're running. And I've seen actually as a whole, we'll talk about that when we get into the overclocking portion, but I'm seeing actually lower voltages overall for I'd say frequencies that we were seeing previously under first gen. So if let's say that 4 gigahertz under Ryzen first gen was in, let's say, that 1.425 category, you're actually seeing a healthy drop down in terms of the amount of voltage to take that same exact frequency, if not a little bit more, on the Ryzen 2. So all the way around, it's really nice improvements, I think, for a performance-oriented CPU and of course, performance-oriented chipset.
Yeah, we'll dig into it when we get to overclocking, but I think most people, it's under 1.4 volts. I don't think we need to go higher than that for a 4.2 in general, assuming you have a cooperating chip. So
yeah, we'll talk about the nuts and bolts when we get there. So what do you think next up? I mean, we've got a little bit, of course, on improvements that you've made in terms of your guys' system utility. We also can dive a little bit more into talking about, I think, the really cool design that you guys have done on the updates to the Wraith. Because I'll tell you, when I got the chance to actual put together a test system and we were doing some demos and run-throughs, I was really impressed. I was actually impressed previously by the quote-unquote first Wraiths when the first Wraiths came out, and this has just been kind of a Wraith on steroids, in my opinion, because it genuinely was able to offer, I think, the balance of what a reasonable enthusiast wants. You're able to get good quality build. It doesn't affect the overall build experience in terms of affecting me from mechanical clearance considerations, whether that's going to be affecting, my DRAM installation, or if it's going to be overhanging on, let's say, an M.2 slot that might be close or something like that. And then in addition to that, being able to provide me a relatively quiet level of operation while I'm under my gaming load or my normal real-world workload scenario. And that's challenging, to find that right balance of being able to get that all packaged into one design that works well and effectively.
Yeah, and the Wraith is near and dear to my heart. I was on the team that came up with the first Wraith cooler. And it's funny, AMD's been around for a long time. We came from a place maybe 3 years ago where if you often would buy an FX processor, you'd get a capable cooler, but it might have been loud, and it might have, and that gave us a really bad rep in some places where and it's funny, if you get a rep like that, you have to do a lot of work to overcome that rep. So we did a lot of work. We put a lot of work into our coolers. We made sure they're very quiet. We made sure they're very capable, and we went out of our way to be the vendor who offers the best possible stock coolers that you can come out at, when you buy a processor. And it kind of got a life of its own after that. It's kind of funny. The first Wraith was on FX and some A series. Then we launched Ryzen, and we sort of wanted this family of Wraith coolers that were all hit that spec, quiet and capable. And then we got kind of went crazy. We said, well, let's play with RGB. Maybe we can do some stuff and make this truly usable for an enthusiast. So from a flashy standpoint, right? Because who doesn't like LED RGB?
Well, I think, it's about ultimately what we see, is really being, forebearers of this RGB kind of focus within the industry, about, first vendors to put RGB on motherboards and then propagating it forward in a big ecosystem. Is I think it's about choice. It's about just flexibility to finding the look and feel that you want with your system. Not everybody's going to necessarily want to have a system that's all rainbowed out in terms of the color aesthetic. Sometimes you might just want to go with a nice simple red or a blue or a green or maybe purple, who knows, whatever it might be. But I think that's the great thing. As we've both been in this game a long time. We've been able to see builds evolve in terms of the look and feel. So I think it's nice that you guys went with an aesthetic that complements, I think, the modern aesthetics that we're seeing in board designs, while at the same time adding that element of easy, illumination and control for lighting. Now, specifically on the Prism, how does the control work? So if you get one of these essentially in the box, how is that going to interface with the boards? How's it going to be managed?
The Wraith Prism will use either a USB controller, and then you can download a specific driver to allow it to. There's a bunch of controls and presets and effects and blah, 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 blah. That's on the AMD website. You can do some really funky things with it. Or you can plug into our partner boards like ASUS, and they have their own utilities so that the board can sync up with what you're seeing on the cooler, so you get the same colors on the whole thing. And I love it's like you say, we've been doing this for a while, and there was a time when there was no lights inside PCs. Like, that just wasn't a thing, right? And it's funny, an analogy I like to use is if you look at the, if you look at the racer scene, guys, really, you personalize your car. There's a certain point where something becomes an enthusiast interest, and then it becomes important to express yourself through it. And it's really cool to see PC owners now, well into that now for a few years. But a PC is really a way to express your individuality and a way to talk to how you feel about it. And buying a Threadripper is like getting an engine upgrade. It's something you brag to about your buddies if that's the thing that you like to do. It's I don't know, it's really cool. So it was cool for us to kind of tap into that and just give people something that's useful. The funny part is the Wraith Prism wasn't originally just hey, let's make a niftier cooler. Really what the impetus was for us to change our top end cooler was we used to offer the Wraith Max. I think you can still buy it, and it's a fantastic cooler from a thermal and look standpoint. Yep. It is a little wide, so on certain boards you get a
little bit of that overhang.
You might be able to touch, or maybe touch a memory stick. You don't really want to do that. So I work with a fellow named James Pryor. He's the guy behind the Wraith Prism specifically. He went and so he pulled it in. He had them pull in the sides of it, so you've got a better profile. And that was really the reason that he started working on this. And they were like, well, what else can we do? So let's make the fan semi-translucent. Let's add more RGB control. Let's make direct contact heat pipes so it cools a little better, right? Yep. Let's we have something
I think we've actually got one free
here. Actually got here. If you guys
actually, we got one right here. So if you guys actually want to show them the other side, we can quickly give them just a little bit of a kind of shot right here. You can kind of get a sense, because one of the cool things that you have with traditional kind of heat sinks design is that it's really about the mass, right? And so here you can see, I think, when you compare this, you've got a pretty nice mass overall. And then you've got, of course, those direct contact copper heat pipes.
Copper heat pipes.
And then they're actually very, very high quality. And we know this from, of course, our graphics card non-reference cooler designs. But you've actually got an integrated copper shim kind of plate that integrates directly within the pipes, maximizing the total conduction kind of surface area. So it's actually a very efficient, a very effective design. I was quite impressed. I think definitely for you guys that are kind of wondering temperature standpoints, I don't know if it kind of mirrors a couple tests that we've seen here. Definitely, I think you can feel pretty comfortable in that 65-degree range. Even running at some of those higher clock speeds under real-world gaming loads, you're going to have good temperatures, quiet operation with cool looks.
Yep. So we're working really hard to get you guys enthusiast class coolers, something you can put in and not feel you have to go buy a $50, $60 cooler to express yourself and to get that thermal performance you need to really take it to the next level.
But wrapping up that point, though, is that with the inherent design, though, that you have within things like XFR, you're going to get actually even a little bit more performance if you do make the investment in higher-end cooling, as well as, of course, helping to even extend your overclocking margin to that next level. So I think you get kind of the best of both worlds. You're going to get a great experience right out of the box. If you want to go with that, hey, you're going to be A-OK. But if you want to pump it up even further, you're going to be good to go.
Exactly.
So what do we got next here?
All right, let's see what we got next to talk about. I'm going to talk about StoreMI because I think I really want people to understand how useful it is and why it's useful and why it's something that you're going to want to consider getting an X470 board. If you guys can show my slides here, I'll just got a few to show. Oh, okay. There we go. I guess you can't. I'll just explain this. So if you guys are like me, you've got an SSD and you've got a conventional hard disk. You've got an SSD because it's really, really fast, and you've got a conventional hard disk because you've got a ton of files. And the problem is SSD is really expensive and conventional hard disks are relatively slow, even though they're really cost effective. So what you end up doing is, at a certain point inevitably, if you're an enthusiast who plays games, you're going to hit a point where you're like, oh, where do I install this game? I want to put World of Warcraft on. It's like 80 gigs, and my SSD is filling up. Do I buy another SSD? Do I put it on the hard disk and take the performance hit? What do I do, right?
Yeah, there's a lot of tricky situations here. I mean, you talk about, the vast majority of AAA titles, they're leveraging between 20 to sometimes 75 gigs. You then also actively look that people forget about that higher memory densities directly translate into higher hibernation and sleep files. So if you're running like 16 or 32 gigs of memory, that's 32 gigs of memory that you immediately lose actually on your drive, because that amount of space has to be immediately allocated towards what's called a hibernation file. So sometimes people wonder, like, where'd all this space go? And it's actually just from that memory being allocated. So you start to add those different pieces up, and you say this is where this type of technology comes in to bring that balance of that performance, but also dealing with the fact that you've got more and more things that are taking up more and more space.
Yeah, and so there's a whole bunch of reasons why it's just not the ideal solution to have these two separate things. Ideally, you could buy a ton of SSDs or a giant SSD and just never worry about it again. That's just not financially feasible unless you're a very, very rich person. So what we did was we contacted a company that specializes in enterprise storage solutions and had them build us a solution specifically for AMD called StoreMI. It's really interesting because it'll take the SSD, it'll take the large hard drive, it fuses them together in a way that your operating system and you as a user, it'll be completely transparent. You'll just see one drive, you install everything on one drive, and it just works. It just works. And at the end of the day, it's intelligent enough to look at what you're doing, how you're using files. After you run a file 2 or 3 times, it says, look, this guy's using this files a lot. I'm going to actually move from a block level, the most used blocks, onto the fastest tier, so the SSD, and the stuff that's not used that much, I'm going to let sit on the mechanical hard drive. The net of this is that essentially it feels like you're using an SSD regardless of how much stuff you have on there. And the interesting part that I found out when talking to these guys, and we're doing a lot of research into this before we released it, but if you install a game like World of Warcraft that's 80 gigs or so, it turns out World of Warcraft only really uses regularly about 3 gigs of stuff. So StoreMI looks at that and it says, okay, here's the 3 gigs, I'll put it on your 128 gig SSD.
Yeah.
So you get this incredible, easy, just works experience, and you don't have to do anything. You just install the software, it fuses the drives together, and you're done. I've ran this since we started talking to Modus. First we released it. You can buy this, by the way, separately. If you have an AMD 300 series board, Modus sells it as fuse drive software specifically for AMD. They don't have it for anybody else, and you can buy that. It starts at about $20, but it comes baked in with X470 boards, and it'll use up to 256 gig SSDs. Now that size is a real nice advantage over our competitors' RST/Optane solution. The funny thing is, you can actually use Optane on AMD boards. You can use an Optane stick and use it. You're probably better off using a regular SSD because they're cheaper for the amount of space you get. But once again, can't talk to how great this solution is. It doesn't suffer the penalty from caching solutions like RST that have to that cache data and have to flush that cache occasionally. It's actually very light on processor usage and at the same time really great for a performance accelerator. So that is a really giant benefit you get with the X470 boards. You get the 256 gig SSD StoreMI software, and you can pair that with up to 32 gigabytes of a hard disk drive. Of course, I don't know if there's a lot of 32, I should say terabyte drives out there.
Yeah, yeah, not yet. We're getting there. I think they just released a 14 terabyte base drive, so wow. It treks on. And I think this is a really nice combination, especially for maybe the more entry level kind of price points that we're going to see, like in our tough gaming X470 series of motherboards, or of course pairing that in, with Ryzen 5 class base CPUs. I think that's going to be a great combination because definitely I think as users step into that higher level of not only CPU, but of course higher end boards, they're probably also going to have a little bit more budget to really dedicate towards higher levels of SSD storage, however that might be configured. But I think, once again, this is giving you that balance that you guys have designed not only within the software, within the chipset, everything kind of tied together to give the flexibility that based on what you want to build, you've got that benefit waiting for you. You can essentially unlock it. Yeah,
it's there, right? You don't have to use it, but it sure is nice to use it if you want to. And who doesn't? I mean, what entry-level serious PC user doesn't at least have a small SSD and a mechanical drive that they can put together and make their life easier? So I think it's really useful. I think it'll be interesting to see how people adopt it because people aren't used to that convenience and they're not used to that idea. I think the enthusiasts who jump on board are going to really appreciate it. And then of course you guys have some really interesting storage options on your boards as they scale up.
So one question to round out there in terms of the implementation. For a vast amount, of course, the X470 boards, it's much more common for them to have two M.2 base slots on the boards. Is there any kind of configuration requirement parameter? So is it only usable in a boot drive configuration, or if you have a secondary, let's say M.2 drive that you want to then pair up with your mechanical hard drive, is that an option? Or what is the essentially requirement configuration for how a user might build this into their system?
Actually, I'm glad you asked that because that's one of the strengths of StoreMI is that you don't have to erase your data. So let's say you built a system on a shoestring and you put only a mechanical drive in it to start, and then you want to add an SSD and combine them in a StoreMI tiered drive, you don't have to erase it. It'll automatically, the software will just combine them so you don't have to restart, reinstall your OS, do all that other stuff. You can do that as a boot solution. However, if you're happy with your SSD as a boot solution and you have a second SSD and a mechanical hard drive, you can combine those. So you can leave your SSD as your boot drive, never worry about it, and combine your second SSD with your hard disk as just a storage solution that is
and I think that's a really nice option, especially for this higher-end chipset. Maybe you see an awesome Newegg deal, right? You got a promo spot, you got that 128 gigabyte drive, you maybe got a 4 terabyte hard drive, and now you can really beef up that nice supplemental storage that you've got to go in combination with your much higher performance single base SSD. So the choice is up to you. You can maximize and have a really nice responsive primary storage volume, or you can get that improved kind of secondary logical volume to supplement your high speed, traditional, let's say, high speed SSD.
That's true. And SSDs, like the pricing, it can't be beat. Like I think you can get 128 is probably $50 on Newegg.
Yeah, I mean, you
start there,
on the
they'll go higher,
but
right? And then 128s probably start a little higher than that, but I should say 256 starts a little higher, but it's not a ridiculous price point to get into. Getting a couple SSDs if that's your thing, man, what a great time to build a PC.
Very cool, very cool.
All right, what else we got to talk about here, bud?
So I think that gives us a good rounding out overall. I think in terms of the new CPU, the new technology improvements you guys have brought to the table, a little bit of kind of some overclocking insights, although we're going to have a dedicated portion on overclocking, on Wraith, and then, of course, on storage improvements. So on our side of the fence, of course, how we, I think, come into the conversation is, we worked really closely with you guys from the very beginning in terms of Ryzen's design and development to be able to, I think, offer, I think, a comprehensive portfolio for X470, for chipset. You know, when we talk about what we want to do from the motherboard design perspective, I think it's really kind of looking to the community and say, what are you guys interested in? Are you guys gamers? Are you guys streamers? Are you guys content creators? Are you looking for advanced productivity? And this platform really allows for any one of those type of users. So it comes down to, I think, trying to develop a range of boards that can try to be targeted at certain budgets, which align with, of course, the CPUs, and then, of course, align with maybe different types of form factors, and then, of course, even different types of aesthetics. So for us, I think now we can kind of jump into some of the really cool things that we have first and foremost on the chipset side, and then we'll get into some of the board stuff. So from X470 on a base chipset, pretty similar to, of course, X370 as a whole, right? We talked about, of course, you have the full support for all the Ryzen chips. It's an overclocking-based chipset, right? As a whole, somebody might compare this and go, well, like, hey, B350 also supports overclocking, so what's the difference? From a board design perspective, we'll tell you that generally the class of board designs that you'll have on X370, while B350 can actually be very capable in terms of its overclocking capabilities and overall board designs, you will get the highest end board designs on X470. So these will generally give you the highest level of, let's say, overclocking capability, while also supplemental features, whether you're talking about cooling, aesthetic designs, audio, networking technologies, storage, connectivity, all those things are going to get cranked up. You're going to go to the next level. We already noted that, of course, DDR4 is par for the course on all the boards. I think one of the most common things that's going to be an area of improvement, though, when people look at storage, everything, of course, we've got all the traditional stuff, SATA 6G support, USB 3.1 Gen 2 is pretty much baked in. Vast majority of the boards are going to have actually USB 3.1 Gen 2 headers available on them. You're going to, of course, have full out-of-the-box support for SATA and PCIe NVMe-based protocols. New for pretty much all the X470 boards on ASUS's range is dual M.2 support, which I think is a big request. A lot of people wanted on the previous generation. They said, hey, we want more M.2, but we're not seeing that as much. So let's go ahead and jump into, I think, one of the first boards that we've got on the X470 side. So we're going to take a look here at the TUF X470 Plus Gaming. So this is maybe new for a lot of you out there. You might not necessarily be as aware for the quote-unquote TUF line. So TUF is actually a line that we've had for a very, very long period of time, but it's gone ahead and gone through a rebranding. And what we've done with, essentially, with the TUF Gaming line is to really be able to offer, I think, an entry-level series product at a more aggressive price point, but that still really meets kind of the tradition and the homage of what ASUS boards are known for. When you talk to anybody that's built with ASUS boards for a long time, they say that they're reliable, that they're quality in terms of their design, and they offer a consistent experience, regardless of whatever you're going to do with that system. And so that's what we really wanted to do, is we wanted to be able to provide users a great gaming foundation. So inherent to the design, you're going to get networking and audio technologies that are designed for gamers. You're going to also have, I think, an aesthetic that's going to be a little bit more stylized towards the gamer's palette, but not be super obscene, not be super heavy. To that degree, though, we've also carefully worked with a lot of partners. Over the next few months, we're actually going to be launching what we call our TUF Gaming Alliance. So we're working with Cooler Master, Thermaltake, InWin, G-Skill, a lot of different partners where we'll have matched accessories. So everything from chassis to power supply to memory. So if you want to be able to kind of start off your entry-level Ryzen gaming build on TUF, you can do that. It's a really nice combination where everything will look, match, clean, and complementary, but without necessarily having to break the bank. You know, it's all being targeted at lower price points. For this board, we're going to be looking at about $160, which I think is pretty reasonable. You know, it'll have dual M.2 slots that are on there. You'll have a solid VRM design. You'll see also the nice shroud implementation that we have that covers the I/O, gives it a nice kind of cool stylized aesthetic. It does feature our audio-based isolation design, where we've got our audio-grade capacitors, shielded capacitor, a DTS audio suite. It will also support Aura Sync support. So, of course, we can see that we've got the Wraith cooler on there. And if you go ahead and jack everything in, you can fully synchronize and control the lighting, either through the Aura suite. And, of course, if you've got other Aura-compatible items, memory, graphics card, those peripherals, they will fully synchronize with it. And I think from an overclocking perspective, while it's not going to definitely be in the same league as our highest end boards, you can definitely still, I think it pairs really well with like a Wraith type solution, and to be able to kind of target in that general kind of target frequencies that you're talking about under gaming workloads. If you're a more demanding user that I think is going to be doing kind of consistent encoding, you know, concurrent streaming and gaming, you probably want to maybe consider shifting to a board that's got more robust VRM, more cooling options, a little bit more capable in that regard. But I think a very, very good choice for a lot of you that are looking for kind of an entry series platform. And connectivity, it does also cover you both on Type A and Type C. So for those of you that are looking for that reversible kind of future-proof connection, you're good to go on that side. Now, moving as we go next over into the stack here, we've got the Prime series. So this is our X470 Pro. So this, personally for me, is probably always one of my favorite series. The Prime series, ever since we introduced, I think, the white design aesthetic, I think it looks absolutely fantastic.
Yeah, I love that look, man.
It's got a really just clean, elegant design. So in terms of that overall design aesthetic, white, I think, has become a kind of really, I think, the second popular most kind of design trend that we've seen there. There's a lot of great chassis, a lot of great accessories, and even if you decide to go kind of the RGB route, one really nice thing you get with white that you don't get with black is that black absorbs all the colors. With actually white, you actually get a natural refraction that occurs. So when you actually put light on there, it kind of shines throughout the entirety of kind of the board and the rest of the system. So it kind of gives you this really kind of nice, bright, evenly lit kind of cool feel. So you'll see in terms of the overall design aesthetic, it's got multiple points of RGB lighting, one zone that'll be right here. It'll have another zone right here. It also features a far more advanced heatsink design. So kind of one of the core tenets that we had with our X470 series boards was what we call is a one-click cool and clocked type of design. And so this was not only giving you easy options to be able to cool your system through software and hardware design, but also through overclocking. So how do we achieve this? Well, a couple of key ways. One, we want to make sure the power delivery solution is capable enough so that as we increase the power demands, as we're pumping up, the clock frequencies, asking for more voltage, the power delivery design is going to be able to hold up. So that means we've got good quality MOSFETs, capacitors, inductors on there, good quality heat sinks, of course, with fins on there to be able to dissipate that heat. There is digital power delivery and control. What that ultimately means to you is you've got good options in the UEFI to really be able to kind of tweak and tune all those parameters that you want to very easily and effectively. And when we get actually into our overclocking demo, we'll show you some really cool options that we have to be able to simplify, I think, the overclocking experience. Now, when it comes to cooling, some of the really cool elements you're going to have is that when you look at a board, you might not necessarily always count maybe the number of fan headers, or you might kind of take for granted, well, what can I do with all the fan headers on the board? And it's kind of interesting because just like there's a lot of baked-in technology you don't necessarily see in a Ryzen chip, there's a lot of stuff that's baked in either into what we call like the Super I/O controller or the firmware on the motherboard that you don't easily see, but it influences your experience. On our boards, we have what we call our Fan Expert 4 technology. This essentially allows for quite a bit more dynamic capability so that when you connect 3-pin fans or 4-pin fans, we can automatically calibrate these fans. So that means we can find out what their minimum speed is all the way to their maximum speed. And we'll actually show you what that looks like here. So we're going to pop over here into our desktop, and we're going to actually bring up our Fan Expert software, and I'm going to be able to show you guys here what the actually interface looks like. So give me 1 second here. Actually, we might need to double check this. Oh, there we go. System's resuming. But the really cool thing that essentially you have the option is that, when you go about building a system, a lot of times you might not necessarily know what type of fans you're going to connect, right? So sometimes your chassis might come with a couple of fans. Maybe those might be 3-pin fans, and you're going to buy like 2 more fans that might be 4-pin fans. So the cool thing is that what we've baked in essentially is intelligent control that can automatically essentially figure out what type of fans you have, and then we can figure out what their minimum and their maximum speeds are. So how does this work? Well, literally you just go into our what we call our 5-way optimization suite. And once you go into the 5-way optimization suite, there's an option that's called fan tuning right here. We can click this. But before we click on that, you actually have quite a different set of options. So like take, for instance, here, I can go over to my fans and I can change them from either having a dynamic, let's say, gradient base of response. I can have them be a fixed RPM. So if I want them to be a static, let's say intake or exhaust, I can do that. You have the option to also be able to do cool things like actually control response time. Response time is extremely important because if you can control the ramping of the fan, you can actually control the acoustics. Because sometimes it's not just how fast that fan is running, but you want to know if you're going from, let's say, 400 RPM to 1400 RPM, how quick is it actually getting there? The faster that it gets there, you're going to get more of a whirring sound than you are from like a gentle kind of swoosh sound. So you can go in and you can have that kind of really granular level of control. But something that's really, really cool is that the efficiency you guys have baked into Ryzen, along with good quality coolers, is quite impressive. And what you actually find more often than not is that your GPU is hotter than your CPU. If you actually measure your GPU temperatures, let's say while gaming. But traditionally, under most normal motherboards, what you're going to have is that all your fans are going to respond to the CPU temperature. But we actually have the option that we can go in and you can change the actual input source. So you can actually have the actual fans respond to the GPU as a temperature input. So take, for instance, like our system demo here. that system where the front intake fans, you could have those actually respond to the graphics card temperature as opposed to CPU.
That's really cool. And as an enthusiast, one of the things that are my pet peeves is having a system where you don't have good fan control and it's doing stuff you don't want it to do, and
Yep.
it just drives me nuts. So
Yeah, and the great thing here too is that for enthusiasts that are out there, you know, we offer all these same class of options directly within the UEFI as well as fully within the operating system. So if you're kind of that more classic user that goes, I don't want to have to deal with any software, you can jump in manually to UEFI and have all these options. But you know, if you want to go through a really nice stylized and clean interface, you can do it in the operating system.
do you guys have presets for?
Yep, of
fan
course.
profiles?
Yep, you have silent, standard, turbo, and full speed. And here we're just going to quickly show kind of what the process is. We're going to see this kind of demo system where the fans are kind of kicking off and on, and they're going to be running through. But the really cool thing to understand here is that in the past, if you would have hit, let's say, a silent button on some type of preset, it's just going to quiet down the fan, because what it's generally going to do is send usually less voltage to the fan. But it doesn't really know what the actual minimum operation of that fan is. But here, what we're actually doing is we're pulling the entire data for all the fans in your system. So when you click silent in the future, if let's say you jump into your web browser, it actually will turn the fan off, because we actually know what quiet is. We actually know what the minimum level of operation is, but then the moment you jump into Battlefield 1, or maybe you jump into, you know, OBS and you're going to get ready to stream something, or you're going to jump into, you know, Premiere and do some, you know, some rendering or some editing, the fan will automatically ramp up based on that workload. So it's a very, very advanced, intelligent type of design, in the same way you have this really robust and advanced technology. You guys have baked in a lot into what we have on the processor side. So I think it's a very complementary level of control. And this Fan Expert 4 technology, while we're highlighting it here on our Pro, it's on our Crosshair board, it's on our Strix board, it's also on the Tough Gaming board in a little bit more basic version. So across the board, you get this class of control.
I didn't even know you could pull a fan.
Yeah.
I'm not a fan guy.
So
I use them, but I don't know anything about
well,
it.
you know, a lot of us, you know, out there as system builders, you know, it's not uncommon now to be investing sometimes $15, $20 per fan for some of these nice higher end fans on the market. So having the ability to have all this targeted information for your system is really nice. So we can now go ahead and pull back here, and we can see our system. If you actually see the fans, they've been starting and stopping because they're figuring out what their minimum is. And at the very end, it'll actually give us a report. We might not be able to see there, but that back fan had actually entirely stopped because it figured out, oh, I now know what the minimum level of operation is. So some pretty cool stuff there. Some other cool things you're going to have there from a cooling perspective is, you know, M.2. It's probably become, I think, the most kind of popular option right now for enthusiasts for immediate kind of storage, because there's no cables, right? I literally can just take my drive, pop it in. But when we talk about cooler by design, there's a right way, and I think then there's a not so right way to be able to do M.2 implementations. So traditionally, many board vendors are going to stick the M.2 slot right underneath the x16 slot on a motherboard. The disadvantage you have there is, guess what's running right there? Your graphics card. It's literally the hottest running component in your system, and you're getting pooling of heat right underneath that slot. For us, we've decided to not put the M.2 slot there. We've put it directly above that, and then we've also put one directly in the bottom lower portion of the motherboard, so it's thermally isolated. So one that allows us to maximize thermal performance, and the one on the top also features a direct contact heatsink. So that heatsink will help to actually keep that M.2 drive performing as high as possible. What we've seen with some of the highest performing M.2 drives that are on the market is they can actually get thermal throttle, just like a CPU. When they get too hot, they throttle down and their performance isn't as high. So if you've made the investment, you can feel confident in terms of the performance of that. So we can see here, if we switch back over into the desktop, it's gone ahead and finished the actual calibration. It gives us all our information. It tells us, you know, everything. Hey, your minimum fan speeds as little as 400 RPM, all the way up to about 1400 RPM. And so all that information is now stored in there. You can back out. You can make your quick one-touch adjustments right here. You can even go to a quick widget, so that if you don't want to open up the whole application, you can go ahead and just quickly select one of the quick profiles, and you're good to go. And of course, you can go into any one of the headers and customize it. You can even do cool stuff where you can actually map the location of where you've plugged in your fans, which is something I think is really cool, because a lot of times we'll plug stuff in, we don't know really, is the front intake fan connected to this header or to this header? But now you can actually go in and you can even relabel those headers. So when you look in your monitoring information, you'll be able to see the front intake fan is chassis fan 1, because you've actually labeled it, as opposed to, in the past, you might look at your monitor and it just says fan 1, fan 2, fan 3, fan 4, right? I don't really know what's going on there. So very, very cool board. And of course, in terms of the rest of your connectivity, all the stuff that you would expect is there. It's an improved audio design where it's got, of course, if we take a look here, audio grade capacitors, shielded audio codec. It's got our full audio suite there that's present on the board. Now, kind of going into that next level, I think for more demanding users is probably going to be this guy right here, which is going to be kind of our step into our more gaming line. So this is going to be the Strix X470-F gaming. So this board, I think, is you can look at it right off the bat, and it's an automatic contrast from what you have with the Prime series. It's just like the Crosshair series where we've got a more monochromatic color scheme on the board. So monochromatic has been put in place because that's another kind of tenet for us, is to kind of make it your own. We don't want to define any one of the boards kind of with a harsh color palette that will contend or compete with your colors, right? If you're going to have RGB lighting and technology built onto your motherboard, you want to be able to define your color choice and not have the board essentially have some type of color that's going to contend with that. So this board fits in that regard. It's got this really nice I/O shroud, of course, integrated lighting. This board will give you multiple RGB headers. You've got addressable and non-addressable headers, so that means you can support the kind of traditional legacy headers for standard LED strips, chassis, even system fans, and then the addressable ones are the new types of LED strips where you can individually control each LED. That's built onto the board. In terms of the rest of kind of the design elements, that's pretty standard, pretty similar to what we have on the Prime Series board, high quality VRM design. You've got the dual M.2 design. You've got the heatsink, high grade audio. On the audio here, though, we've changed things a bit, and now these boards will actually come with a bit of a different software suite. So I'm going to show you a little bit kind of what this software suite looks like.
Speaking of the software suite, I just have to say, because you've been around for a while too, and I remember the day when motherboard utilities didn't look that easy to use.
Yes, yes.
Didn't have the best user interfaces, but this actually looks really intuitive and pleasant to have around. So
yeah, no, I mean, 100% with you. I mean, we've spent a lot of time to be able to try to ensure that the software meets, I think, an enthusiast standard. In the same way that you guys have done a lot of work with things like the Ryzen Master utility, it needs to be able to be lightweight, responsive, and ultimately serve its function easily and effectively. You don't want to ever have that kind of that banner of it being called bloatware, right? You want this to actually be beneficial to an enthusiast, and that's what we've really tried to do. So with Sonic Studio, you've got a lot of great options that are built in here, where you've got, of course, specialized presets for music, movies, games, communication, but there's a lot of targeted options that are very easy. So if you want to be able to have filtering to be able to improve voice clarity, so let's say you're in in-game chat, whether you're doing actually audio that's coming into your system or audio that's going out of your system, you can actually apply post-process filtering to that to be able to clean up that audio. We've got, of course, options where you can go in and you can apply what we call per profile audio settings. So if you want to be able to have like audio settings specific to Chrome and Spotify, right, you can have specific audio settings set for that. But the moment you jump into your game, you've got another set of audio settings that apply to that, so that you can really conditionally set up everything the way that you want it, and you don't have to kind of go like, oh, I want this music preset bass where maybe I want more bass when I'm listening to my music, right? But I want more treble and more ambience when I'm gaming, right? So you can go in, you can customize all this, and it's application dependent. So as applications open up, you can go in, you can target different things. We have a full custom option specifically just for casting. More and more people are streaming, so you've got a lot of really rich options that are in there. So you can see here we've taken kind of the very good quality hardware audio design that we had on the Prime, and we just took it in even further by giving you a richer software suite on this board. Now, kind of last but not least here, because then we keep moving on, is that you'll see another really cool item that you're going to get here on this board is the fully integrated I/O shield. So as a builder, both of us have been building for a really long time.
Oh, I love it so much.
One of the golden kind of things that people always forget is to put in their I/O shield, and now it's just fully integrated on the motherboard. And of course, there you can see you've got all that great I/O too, right? You've got high-grade NIC with our packet priority software. You've got your USB connections, your Type A and Type C. You're all covered right there. And of course, everything else that the board's got you covered. So from here,
JJ, did you ever have a case where the eye shield holder just kind of broke or was bent? Yep. And you spent just a giant,
you spent some time kind of wrangling
inordinate amount trying to get a shield on. I just want to mention that.
No, it can be extremely challenging. So this actually not only serves the benefit of actually making it easier and that you don't ever have to worry about it, But actually, not a lot of people realize that the I/O shield is actually there for ESD protection. Without it, you actually significantly increase the likelihood of electrostatic discharge because you're literally plugging in so many devices. It's a point of contact failure on boards over time. By us being able to actually bond the I/O shield directly on here, we actually can improve ESD performance by a significant percentage. So not only is it more convenient, it actually improves the overall reliability of your motherboard. So while you're going to spend a little bit more to get a board like this, you're not only getting something that's more convenient, but you've also improved the overall safety and reliability for your product. Pretty cool. So here we now step up to really the flagship. You know, ROG is a very special brand for me and of course for ASUS. It's now been in the industry for over a decade, and it's got a very special relationship with AMD. The actual first AMD motherboard for ROG was an AMD board. And the Crosshair boards have really had a long lineage of really kind of consistent benchmark performance. In fact, I'm excited to announce for this chipset launch, we've already done some really, really impressive stuff. You know, when we talked a little bit of overclocking, we're going to get into our overclocking demo here in a little bit. The Crosshair has already hit 6 gigahertz now on second-gen Ryzen parts. We've done some monster numbers in terms of DDR frequency over, I think, 4,200 megahertz. So, you know, and that's just right now in the very beginning, and we expect to continue to even see more performance out of that. So when we talk about really building ROG, a lot of people wonder, well, you know, if this is an ROG Strix board, what do you really get when you go to an quote-unquote ROG motherboard? And the first thing is that it's designed and developed by actually a specialized team that really looks at every single aspect of what we can do to improve the board. So right there, I think that's a beautiful shot that you'll notice right off the bat. The board features an absolutely beautiful, clean, full matte black kind of aesthetic. Kind of our goal here was to really be able to offer, I think, enthusiasts that complete contrast option. If you wanted to go for a full blackout look aesthetic, no RGB lighting, you could entirely do that. But if you want to have the most extensive type of RGB lighting control experience, we also wanted to give you that. So what did we do? Well, 2 cool things. If you want to go entirely all out and just be minimal and black, the board features an exclusive special what we call stealth operating mode. It's an option within the UEFI that will disable every single onboard status LED included. So normally, even if you were to quote-unquote turn off RGB lighting on a board, you'll still have like activity lights or a power light on the power button, stuff like that would still be active. Here you can turn all that off. On the other end, if you want more connectivity and control, there's 4 total RGB headers that are built onto this motherboard. So you can pretty much connect every single thing you would want. A chassis, LED strip, fans. And
I should also mention,
all on there.
If you want to run dark, the Wraith Prism has a dark mode.
Oh, that's very cool too.
So, RGB heathens out there.
For those of you who want to keep everything exactly minimal. Now, beyond that, we've also done some very, very big upgrades. So the VRM is also going to be considerably more beefy. This is going to feature a much higher grade in terms of the MOSFETs, the capacitors, and these are going to be power stages. Mostly on more general boards, you don't usually have what's called a power stage. You have what's generally called a MOSFET and a driver. It's a kind of 2-package design. Here we go to a much higher part. It runs lower in terms of the temperature. It has more leeway. And what this just means is that essentially is that it's kind of think about it like an 850 watt silver power supply versus an 850 watt titanium power supply. One has much, much higher quality components, can run more efficiently, and has overall better performance. And that's the same thing that you get here. You get a much higher VRM. VRM has also been improved in terms of its cooling design. This features a direct heat pipe that integrates between these two, where let's say on the Strix you don't have a heat pipe. You've got 2 high performance heat sinks, but no heat pipe. Another cool thing that you won't see, it's kind of hard on the board, but this actually board features a special, if I can get to it there, it's actually an external clock generator that's built onto the board. So one really cool thing in terms of overclocking support that AMD allows for on Ryzen parts is you can do bus clocking outside of just multiplier clocking. Disadvantage though when you do this is that you are going to adjust all your other buses if you adjust the bus clock. So we can essentially decouple your bus. So you can go about and do your bus clocking without influencing, let's say, like your PCIe bus or other buses that you don't want to influence. So this board exclusively has the ability that you can go what's called an asynchronous overclock or non-asynchronous based overclocking support. It features, of course, the M.2 heatsink design. You have, of course, the other M.2 you can see right here. Now this board, though, will also be the only one that we will offer that will give you full by 4 M.2 based rated configuration support. So normally this wouldn't be an option on most boards. Most X470 boards you're going to get this secondary M.2 slot is going to pull from the PCH lanes, But here, essentially, we can divvy up so that if you're running one GPU, we can take some of those PCIe lanes from the CPU and divvy them out so that essentially you can maintain the highest level of performance for both your M.2 based SSDs. Down here in terms of the water cooling zone, there's some really cool connectivity so that if you've got custom water cooling pumps, you can go ahead and have custom connections here. If you also want to monitor what's called your water flow and your temperature for your inlet and your outlet, you have custom headers that are available to you here. And when we take a look here at the back I/O, if we take a look right here, you can see that this board is very, very stacked. So you've got tons, of course, of USB ports on this board. You've got integrated Wi-Fi right here. So you got dual band 802.11 AC Wi-Fi with multi-user MIMO support. Of course, your clear CMOS, USB BIOS flashback button, which is really often for enthusiasts. You can literally update the BIOS on this motherboard. You don't actually have to install the CPU. You don't even have to install the memory or graphics card. You can just connect the power supply, put a flash drive, click a button, and low-level flash update the motherboard. Nice. So very, very, very cool stuff. And on the audio side, you get the same audio package that we've kind of shown, but here in this section, we took it to a whole nother level. We actually integrated an ESS Sabre DAC. So if you've ever heard kind of this term DAC, where you can apply advanced post-processing to really kind of improve tonality and sound stage, we built onto the motherboard. So really in every regard, kind of we've upped the ante to be able to kind of give you more. So I think here we want to jump into quickly just showing you kind of how Aura ties into all of this, and then let's do some overclocking, talk about how that ties in.
Sounds good.
So when we talk about that, pretty much all these boards have headers that allow you to go ahead and have synchronized control. If we take a look here at our demo system that we've got set up right here, this is a pretty nice build. We've got a Crosshair VII Hero here. This is a 2700X and RX 580. Then we've got a Fractal Designs chassis. This is the Mesh series. And then we've got a Cooler Master cooler along with Aura supported fans. We've got a Cable Mods addressable RGB LED strip. So the really cool thing about this is that it all can be fully synchronized in control. Even, of course, our team group memory that we have in there, which is also Aura synchronized. So how does this all work? Well, let's go ahead and pop over into our desktop, and we can take a look here at the Aura interface. So what you're going to see at the top, and this is in our new update, we just released this a little bit ago, is you'll see every single one of your devices available to you. You can select which devices you want in terms of configuration. From there, you can go ahead and set whatever color you want. You've got options where, of course, you can go all throughout the color wheel. You can individually go actually by area, so you can see literally every single area. You could select it and change that. You could adjust saturation and brightness. It's all up to you. For most people, though, I think that they're generally going to go either with like a breathing or a static effect. So here, we're going to go with red. That's, I think, a great color for AMD.
Let's go a little bit more orange.
A little bit
what do you
more
say? Just a little bit, just a little bit orange.
So we can go a little bit there.
There you go.
And we can go there. So
Ryzen orange, folks.
So there we go. So we can see now that's easily synced now entirely across all of our components, even down to our mouse and a keyboard, and even this monitor. This is our XG series monitor, which features Aura Sync support. So if you throw this up on the back wall, get that little lighting. So really, really cool to know that all of these boards that support ASUS Aura Sync are going to give you this capability. Now, before we get into the overclocking, I do want to touch on one last board that, while it won't be available right now at launch, is going to, I think, be very interesting for you guys out there, and that's going to be Mini ITX. A lot of you were really interested in having a Mini ITX offering when it came to the last generation, and we did release one. A lot of people absolutely loved it. And so here we have gone ahead and, I think, taken that and just taken to the next level. So this is going to be the X470-i gaming. So this is part of our Strix family. You get very high quality VRM, so you can feel comfortable in terms of even 4.2, 4.3 gigahertz overclocking is going to be capable on this Mini ITX board. This board will feature the M.2 heatsink design. Right here, you can see I've already got an M.2 inside there. This is a heatsink that makes direct contact right there. And then even for you guys that want to run a second M.2 drive, there's another M.2 slot on the back of the board. So you've got dual M.2 support that's built on. You guys got very high quality DRAM designed here, so you can get very, very good quality DRAM clocking performance. On the back, you've got all your connectivity that you could ask for in terms of your USB 3.1, you've got your 802.11 AC Wi-Fi, and you'll see that the audio looks a little bit different than most boards, and that's because even the audio has actually been upgraded. Most of the motherboards that we all talked about essentially all have that isolated audio design. Even on this Mini ITX, this motherboard doesn't actually have the audio on the physical motherboard. It's been isolated on its own discrete card to be able to maximize its overall signal to performance ratio and really be able to offer you an outstanding audio experience directly on board. And here, even with that Aura Sync, you still even get two of those headers directly on this board. So you get that great Fan Expert 4 technology. You're going to get the auto overclocking technology that we're going to talk about. You're going to get our Game First packet priority software, which works on the physical NIC and on the Wi-Fi. Dual M.2. I mean, the board's packed in, even though you're talking about a really small form factor board here.
And don't forget to mention, this is your first Ryzen Mini ITX board with a video out.
Correct.
So you could use a Ryzen with Radeon graphics like a Ryzen 5 2400G and go to town in a super tiny, slim little enclosure.
I think that would work really nicely, especially if you're looking to be able to have a box that maybe is focusing kind of on popular, kind of battle royale type games, MOBA type titles where you can really get that great performance out of that integrated graphics core. You still got overclocking support that you can go ahead and maybe punch up a little bit more performance as well, all on a really nice compact profile.
Media PC.
Yeah. The last point here before we get into the overclocking is also as kind of a really cool update for you guys that are checking out the stream. An announcement that we have for ASUS Aura is also for those of you that are Philips Hue users, we are integrating Philips Hue support. So that means that essentially within Aura, if you've got a Philips Hue set up at home, you'll be able to extend your Aura battle station look and feel to now your actual system lighting that you might have in your room or in your immediate environment. So that's going to be pretty sweet.
Yeah, it's pretty nifty. I don't know if you guys have seen that, but you can get lights in your wall and have your PC attached and have the color effects, and it's pretty trippy stuff. It's kind of nifty.
So I think one of the last parts here that we get into is going to, I think, be when it comes to overclocking. Overclocking, we're talking about an overclocking-enabled chipset. It's one of the key aspects of that, although you guys have made kind of overclocking really for everybody, right? Because it's on B350, it's on X470, it's across all your CPUs. And you guys have extended the overclocking headroom on this generation CPU. That being said, we've both been in the game for a long time, and I think we're comfortable knowing about things like ratios, multipliers, offset voltages, manual voltages, whether you want to have your VRM operating in a current dependent mode, or if you want a temperature operating mode. But for a lot of people, there can be a lot of complexities to this. And it can be sometimes challenging to know, okay, if I made the investment in a good quality motherboard, a good quality cooler, a great CPU, how can I get that extra performance that everybody keeps talking about? And so at ASUS, we've spent a lot of time to really try to figure out how can we do this easily and effectively for you, but mirrors the same type of performance that you would have if you were a seasoned manual user, that you could go in. Now, you guys have some really great options with, I think, in the Ryzen Master utility, right, which will give you a wide range of options. So we actually can show you what that looks like here before we jump into our automatic utility. Hold on, we've got actually this system utility up here. And with, sorry, oh, I already have it open, that's why. Okay.
There you go.
So, there's a lot of really great information that's here. Like, you guys have given it the ability to see, actually, actually, I can let you speak to it.
Yeah,
you can give a couple of quick.
I'll really quickly give the notes. I'm going to find my notes but essentially what we've done is we've indicated we've indicated the fastest core on the processor, and the fastest core per CCX. And then I should say the fastest core per CCX and the second fastest core per CCX. We also have per CCX overclocking.
And that's new. You didn't have that in the previous generation.
We did not have that before. So way more control for you guys who like to tweak certain specific things. We built in a stability tester for guys who really want to quickly test their settings, make sure that things run all right. And we've also put a bunch of back-end work into some potential interesting, I guess I can't even talk about it yet, but some potential interesting features we might look into in the future. So we're kind of changed the framework a bit to see what we can do with for our enthusiasts who want to overclock.
And I think that's important to note that just like things, that's just like software and our UEFI in general, these things evolve and get refined over time. So that's one of the great benefits of now kind of having a software firmware type of layer that can be worked with in the operating system, is you have the ability to keep adding in more functionality and feature set as you get response from the community.
Yes. But I will add, though, that what we don't have, so it's a very simple interface. It's made to be really easy to do, but what we don't have is an auto overclocking utility. So it won't automatically overclock for you. It's a manual overclock utility. You have to tell it how far you want to go. Yep. But ASUS has done something a little different.
Yeah. So, but I will say that for those of you out there that kind of scoff at wanting to do this as opposed to the UEFI, while we're going to have awesome UEFI options in our boards to be able to manually tweak things, it's quite a bit easier to be able to do this in real time within the operating system and stress test without having to go through so many reboots. So I definitely recommend, whether you want to use Ryzen Master Utility or our auto-tuning technology or our Turbo V software to be able to execute that, it's going to save you a lot of time to do that.
And if you're a manual guy, just test it out, play with it in Ryzen Master, and then put it in the in the BIOS if that's how you want to do it. But it is nice to be able to just tweak stuff on the fly.
So let's go ahead and jump into this. So with AI Suite 3, you're going to have what we call our 5-way optimization and our auto tuning technology. So this is going to apply to our mini ITX board, the Strix board, the Crosshair board, and the Prime board. The Tough board does feature a basic auto overclocking option, but it's limited to within the UEFI as it's a little bit more basic board. Good for kind of just some basic targeted kind of overclocking, but this will be what we call system specific to your CPU, specific to your cooler. So literally, if you ran this on 2 exact different systems, you're going to get different results. So we're going to go ahead and open this up and show you what this looks like here. So all we're going to need to do is we're going to go into TPU. Once we go, within TPU, you'll see that we have all the different options like you would have, like similar to kind of like Ryzen Master, and that's for your manual enthusiasts. But here we want to go into our 5-way optimization suite. So right off the bat, if we didn't want to do anything, we could just click Start and we'd be off to the races. But we're actually going to just quickly break down what some of these options are. One, we have a quick tab to let you allocate stress test distribution. So you can go ahead and allocate how much you want to stress test the CPU as well as your memory. Memory is important because as we clock up the memory, you want to make sure that you're stressing that memory controller and the amount of memory that you have running at a higher frequency, because sometimes if you're not stressing the memory, you might get a crash and think, oh, it's because my CPU is too aggressively overclocked, and in fact, it's actually instability in your memory. So it's important to be able to do that. And I usually recommend a fully maxing that out, because that's going to be a good mix, especially if you're kind of opening a lot of tabs, you're switching between applications, things like that. The really cool part here is we have a custom level to the stress test duration. So we've done a lot of work to really kind of dial in that if you pick about probably 60 seconds, it's going to probably be about 85, almost 90% of the time, it's going to be fully reliable. Be very stable experience. But if you really want to maximize it, you could set an hour per each increment. Now keep in mind, we're going to increase the clock speeds by 25 megahertz. So if you had a lot of increase, right, so I could say it's reasonable to expect maybe 500 megahertz overclocks from base to peak on, let's say, like a 2700X with a good quality cooler. That could be hours, right? So maybe you want to set it when you're going to bed, and when you wake up in the morning, you've had all these hours of stress tests, right? CPU state ratio stability, you could easily just go ahead and select normal or encoding. So if you maybe are doing streaming, you're doing rendering on your system, you can do that. Very simple to test that. And the last 3 options I think are really cool. One, you could dial in how much maximum voltage you want to apply during this auto overclock. If you don't worry about it. We'll automatically manage it for you. You could also pick a target frequency, so that if you just want to go ahead and select, hey, I don't know if my CPU can get here, just put it there. We'll attempt to automatically get you as close as we can there. If your system allows for it, we'll get you there. If it can't, then we'll get you to whatever the closest value is. The last one I find very cool, even for super dyed-in-the-wool enthusiasts. And this is literally an option to be able to target your overclocking based on temperature. So instead of thinking about a frequency in mind, I could say, I want the best overclock to my system until it gets 80 degrees. Right. So I set 80 degrees, and if that means 4.2 gigahertz, that's what I'm going to get. But if it means 4.4 based on a really good cooler, then that's what you're going to get. So it's a really cool option that normally would be very complicated for a manual user to try to kind of track and manipulate all these options.
And that means you can target, let's say, even a sound level.
Correct.
Basically, if you're that guy who needs it to be a certain amount of sound.
Of course, yeah, because of course the lower the temperature, the quieter the overall footprint. We also tie this into those fan technologies, so that if you wanted to literally run our fan calibration right after you do all the overclocking, that could all be done at the same exact time. So we've really simplified this, and this is why we call it our 5-way optimization suite. So we're just going to go ahead and essentially all that I've done, if you notice, I literally just fully put out the stress test duration, and the stability I set essentially at encoding stability. So at that point, I'm just going to go ahead and click Start, click Yes, and the system's going to reboot. We're going to lose this feed, so we're going to come back and we're going to let it reboot, and then we'll come back to it, let you see what it's doing while we fill in some of the gaps here in terms of overclocking. So
does it have to reboot every 25 megahertz, or is it going to do this on the background?
So what it's going to do right now, and that's a great question, is that right now it's actually talking directly to the motherboard. It's beginning essentially the process of setting in a baseline preset overclock at 4 gigahertz, and once that reboot occurs, everything will happen 100% in full real time within the operating system. So it's going to be talking directly to the motherboard using the firmware interface layer. So voltage is going to be adjusted in real time. Multiplier is going to be adjusted in real time. We're going to track the wattage. We're going to track the voltage. We're going to track the temperature, all while stress testing the system, all in real time. So all of this will happen actually exclusively within the operating system, because that's the only way you can stress test. Even if you manually do it, you have to make your changes, reboot, and go into the OS. So from here on out, we actually will not get, excuse me, give me 1 second to log in here. We will not have to enter into the UEFI or do anything because all the changes will happen right away within the operating system. The next reboot that essentially will occur will actually be because the system is not stable. It's reached its maximum level of overclocking. And again, like I said, I reinforce the fact this is system specific. So even location specific, not a lot of people realize that you can have variance in electrical quality that comes from your infrastructure environment. A lot of different things can change your overall overclocking experience. So, you know, two friends could build the same exact system. You could build the same exact system that we have right here, and maybe you get a little bit better result, or maybe you have a different one. And that's something that we talk about here in terms of overclocking. While you guys have helped to extend overclocking margin, and I think as a whole, most people are going to see better overclocking results on Ryzen 2nd Gen than on the 1st generation, there is still the silicon lottery, right? For those of you not to know, essentially that just means that every CPU is a little bit different. Every CPU
Pardon me.
is going to have some variance in terms of what it's going to be able to reach to you. You guys enable at least all of them to be able to be tweaked and tuned, so all of them can be able to get to higher levels of performance, but what that maximum level is unknown, right? So if we switch back over here to our desktop, we're going to go ahead and let this run in the background, but we'll actually see right here, it's gone ahead and given us our 4 gigahertz. Now this is across all cores. So we're just going to open up our task manager here for reference so people can see what's going on here. Now if you were happy with this is of course not necessarily maybe fully maximizing the way the CPU could work, because of course you guys do give potentially peak higher performance under a lighter thread workload because of XFR and you know, precision boost. So here we're hoping to get a little bit more across all the cores, right? So we're just going to click continue. And at this point, what you're going to see is happen is you can see now it's going to go to 425. So it's now essentially a little bit over 4 gigahertz, and this is on, you can see right here, all of our threads right now are under 100% utilization. Our memory is now fully being pulled in terms of also being fully hammered, so we're stress testing memory and the CPU in real time. We're tracking our temperature right here, and this is reading direct T-die temperature, so this is representative of kind of enthusiasts, what you want to know in terms of your temp. We tell you your current and your maximum. We tell you your voltage, and then we also are tracking your wattage. Now the cool thing also on the voltage is that we are maintaining using an offset voltage. So talking about overclocking, for those of you who don't know, you guys have 2 options that are available for the CPU to be manipulated in terms of voltage. One's called a manual or static voltage, and the other one's called an offset voltage. And the reason why we use an offset is that it's a newer type of option, but it's far more efficient. The benefit that you have with an offset is that as the CPU frequency is going down, the voltage can go down, and it can dynamically go up and down. So overall, it helps to extend the lifespan, produce less heat, consume less power, as opposed to a static voltage, which has its place sometimes for the most aggressive, demanding, high-level overclocks, but it will consume the most power, produce the most heat, and over time can degrade the CPU maybe a little bit more than what you would have with an offset-based implementation.
Now this is a pure CPU overclocking utility, correct?
That is correct. So our boards actually do all offer an option built in within the UEFI that we call DOCP memory profiling. So this is a very common question we get is, you know, a lot of people go out and buy memory kits, and they don't realize that their memory kit that they buy, this is some G-Skill memory, 3200 megahertz. By default, if you stick this in the motherboard, it's going to run at 2133. Even though you guys support higher memory frequencies, well, how do you get there? Well, all our boards, we have an option that allows you to essentially read the overclock profile for the memory, so the frequency, the voltage, and the timing, and we can automatically apply that to our motherboards. So we can really help to simplify the experience. So if a user wants to maybe apply that value, check, make sure their system is stable, they could then still run this, and so then they could have that best of both worlds. We can balance out both the CPU, get you overclocked, as well as your DRAM. Now, we don't do both right now just because we have significantly improved the overall compatibility, I think, testing. For ROG motherboards alone, we've done over 650 modules that we've validated. On our other standard series range of boards, over 400 modules. So a lot of work to really make sure you guys can feel confident in terms of interoperability and compatibility. But auto-applying a memory without knowing with, I think, the highest level of confidence that we can ensure that stability is why we don't automatically overclock the memory, but the boards are definitely capable of it. But we can see right here, it's still continuing to improve in terms of its frequency, and it's going to keep running through its test until it essentially hits its wall. For you, in terms of, you know, if you want to give a recap, what do you think are overall kind of the target ranges that users are going to be seeing in terms of their frequencies right here for Ryzen 2?
Well, like I said,
And second generation.
assuming we've got a decent cooler, the Wraith Prism hits that mark, right? But assuming we've got that or better, we are seeing generally, and like I said, it's a lottery, so this is not a guarantee. The lawyers will get all over me if I say something like that. But I haven't seen a chip yet that hasn't hit 4.2 all cores at 1.4 volts to 1.375 or so.
I'd say that. I'd say you're looking in between about that one. I think if you've got a really cherry kind of low leakage CPU, maybe 1.35, maybe a little.
I've seen guys hit 1.3, a little higher. But
yeah, I think around there, and then I think like I said, probably more normal is going to be in that 1.375 range, and then maybe a little bit more leaky chips, maybe up to around that 1.4 volt range.
Yep. Exactly.
Now I will note, for some of you also might be wondering about voltages. That's a good point. Another difference that you're going to actually have in our board designs, many people don't know that the tracking for voltage actually can vary depending on where you put certain monitorings of certain control sensors on the motherboard. So on the actual Crosshair, we specially designed actually putting the controller directly on the power plane for the best access to read direct voltage for the CPU. So many users sometimes are going to go, why am I seeing subtle differences? And the reason being is that sometimes the further away that you maybe put a sensor on the board, it actually has more resistance. There's physical proximities that actually add an influencing characteristic into how characteristics are being read. And this is different than what you are defining or programming in. It's actually what's really occurring. So we actually have some specialized board design here to be able to maximize accuracy, especially if you take advantage of this guy right here, which is going to be the direct contact read points that we have on the board. So if you use a multimeter, you can get really, really high level accuracy in terms of voltage monitoring.
Now, as a guy who works with motherboards, what have you seen as the defining characteristic that would help, the high-end ROG versus the Strix? Is it the VRMs would help? Is there something else?
So that's a good question. VRMs really come into a couple of things. I consider it almost like buying a really good quality cooler. If you bought like a nice Noctua U12S versus like a U14S, the actual overclocking headroom or capability is almost the same. It's just one will be able to achieve the same frequency, but maybe be able to operate at a little bit lower temperature and a little bit quieter operation. And I think that's kind of similar to what we've done here. The VRM design on the Strix compared to the Hero, they're both capable, and they both could be able to achieve, let's say, a 4.2, a 4.3 gigahertz overclock across all cores. But the VRM on the Crosshair is going to be able to comfortably maybe have that operate at maybe 10, 15 degrees cooler, right? Okay. And if you as a user feel that comfort level of knowing your components are running cooler and also have more margin inherently built into them, that can provide you sometimes an inherent benefit. Now, it is true that some components, the hotter they run, they essentially have more difficulty reaching higher levels of performance. It's a smaller differential in terms of how much that really is helping you to eke out. But what I would say generally does occur is that with ROG series boards, you're going to get unquestionably far more advanced options. So while my system is overclocking here, if actually we cut back over to the desktop, I can show you some of the key differences. An example of this will be we're going to have more specialized profiles. So take, for instance, we have a dedicated team of overclockers that create customized special profiles for, let's say, DRAM memory kits. You can see right here, I think you'd probably be surprised, but we have program kits for like 3600 megahertz pre-programmed out of the box. If you buy these kits, you can go in and we've pre-programmed every single parameter on the board to be able to auto-configure and load up this board and have it run that memory. That's not, you're going to get that on every other board. So these are where you're going to get subtle differences in the ROG boards where enthusiasts that are looking to maximize performance on every area, or they're looking to maybe overclock their CPU and then overclock a little bit of their bus clock to even get a little bit more bump, right? That's where there's going to be options that are inside here that allow you to kind of extend the performance. So I think it's really a combination of the hardware design, then the firmware, which is the UEFI, and kind of both tied in together to really be able to kind of help to extend that overall experience. But we do feel very confident. We have a lot of people ask, do you guys test? All the boards go through a qualified overclocking based test internally in the labs under very demanding stress tests, high ambient temperatures, to be able to ensure that we feel comfortable that, hey, say, you can meet a certain marker. But when you invest in a higher end board, essentially you're just giving yourself more leeway and more options, is what I would say. Now we can see if we just circle back here where we're at. We're now 4.125, and we can see here it's of course stressing across every single core, all the memory, and it's still going up, no problem. So we'll continue to see ultimately what it sells on here. But rounding out, I think, some of the other elements, when we talk actually about the UEFI, there's some cool things here as well that we didn't note on. ROG board also has secure erasing built in. I don't know if you're familiar with secure erasing, but a lot of enthusiasts, when you hit your SSDs over time, sometimes they can get degraded performance, and sometimes you need to factory reset them, essentially clear them out so that you can get back to 100% performance. Normally this requires special utilities from the vendor. Not every vendor that makes an SSD offers these, but we now bake this directly into the UEFI, so you can just secure erase your SSD. UEFI updating is probably the most important thing, right? We know that AMD releases a ASUS to us. We do performance testing. We bake this stuff in. This gives you improved compatibility, performance, overclocking. But it's always been a pain point because if you're first setting up a system, you actually almost have to have another system to download the updated UEFI,
Yes.
put it on a flash drive, then plug it into your board and update it. Well, we tried to make that easier with the USB BIOS flashback technology that we talked about on the motherboard. But now in the UEFI option, if we show you here what that looks like, you see that there's two options, one that says storage and one that says internet. You literally just have to connect your internet connection to the board and it will download the update, just like if it was downloading an over-the-air update on your phone or your tablet. You don't even have to go to another computer to download the UEFI anymore. So when you're first setting up your system, or if you want to easily update it, just go ahead and make your connection, update it, and you'll be good to go. No flash drive, no downloading required. Just connect your Ethernet cable and check. We've also got a fully customized menu, which I think is really cool. A lot of people get confused. There's a lot of options within the UEFI. Now you can make your own favorites page. So just like if you've configured your browser with your top 10 favorite pages to go visit every time you open up your browser, put in the top 15 options that you want in your UEFI, and you'll see those all on just one page. I don't got to dive into 4 separate parts. I don't need to go here to adjust my fans, here to adjust this, here to adjust this. I can just put everything on one single page. And I think one really last option is one that I have literally been trying to get my team to put in for, I don't know, 5 years, I think, maybe. But that's search. We have built in search into the UEFI. So now you can actually put in key strings. So like if I want to do multiplier or voltage, right? First time user, even an enthusiast user, maybe it's in all these subtrees, I don't know where it is, just type it in and we'll give you where the value is.
Nice.
So some really, really, really cool stuff. So a lot of different ways that I think we're making overclocking easier, we're simplifying it and giving you great options. So you can see here it's gone ahead and get now up to 4.175 in terms of the actual frequency, and it'll continue on pretty much until it crashes.
So you didn't set a specific clock, you just told it to go as far as it wants to.
Goes as far as it goes, and so it'll, depending on the quality of your CPU, like I said, this will be variable, but this overall I think gives you guys an idea of just how easy it can be to effectively overclock your system. And you know, once you're all finished up with that, you know, you could jump into Ryzen Master if you wanted to additionally maybe stress test your system. We also have our own application called ROG RealBench, which we've openly made available to the community. It's all using open source applications like Handbrake, Blender, GIMP, where we use real world programs to stress test your system. Both single threaded and multi-threaded, even leverage OpenCL, a lot of cool stuff to let you get a score from stock and then compare that to overclock and see how much you've improved your performance.
It really talks to second gen Ryzen to see something automatically going to 4.2.
Yeah.
Without having to manually tweak a bunch of things.
Yeah,
that's kind of nice.
And I think a lot of reviewers and a lot of enthusiasts that were familiar on first gen Ryzen, this would have been like, you would have been doing backflips.
Yeah.
If you would have had a 1700 or an 1800X and you would have been a 422, you would have been like, I have the best CPU out there. So the fact that we're able to do this literally, just like I said, a click of a button, I think is fantastic. So overall, you know, that pretty much, I think, wraps up most of what we wanted to dive into. You know, we've talked about, I think, a lot of different aspects, you know, regarding from, of course, I think, architecture to, of course, all the performance enhancements that you guys have brought to the board, cooling improvements that you guys have brought on board, of course, with all the coolers now incorporating in-box cooling support, improvements on the chipset side. Of course, what we've done on the ASUS motherboard side, I think you guys have seen, we've got an awesome range of motherboards that they're all available right now. With the exception of this mini ITX guy, you'll be seeing this guy in the not too distant future popping up here on Newegg, and you'll be able to gobble it up and be able to build some really awesome high-end performance rigs. Hopefully you guys have been able to see that we are really committed to offering you guys, I think, outstanding options to be able to easily cool your systems, overclock your systems, customize the look and feel for your systems, give you great options in terms of audio and networking. And I think overall just some awesome ways to really be able to take advantage of what AMD's done with the latest generation X470 chipset and the latest generation Ryzen 2 second gen parts.
Yep. And
so very cool stuff.
It's been a privilege Thanks very much for your time, everybody. Thanks for.
Sorry to interrupt, Don. We actually got your feedback. If we can exit out of full screen and mirror your display, we can actually get your PowerPoint back up for the people who missed it.
Oh,
If you want to do that.
I think I described it appropriately. I think we're good.
Okay, cool.
Yeah.
Yeah, overall, yeah, I think that covers that. Of course, for you guys will be able to go check this out, review this. We've covered a lot of different pieces of information here in this stream. So if you guys have any questions, comments, feedback, whatever it might be, feel free to go ahead and drop them into the comment section. We'll do our best to go ahead and check that out, see if we can get back to you guys. You guys can also drop us a like, and you like seeing AMD and ASUS here. We'd love to hear that so that we can go ahead and maybe work on future projects for you guys similar to these type of live streams. And you guys can also go ahead and click that subscribe button because you're watching this great content here from Newegg Studios. So with that, I'm looking forward to seeing your guys' latest Ryzen 2nd generation builds based on hopefully some awesome ASUS X470 series motherboards out there on the forums. So with that, take care, take it easy, and enjoy the rest of your day.